Hello, young people. Today we're going to discuss synthetic division. And all synthetic division is a simpler way to divide the polynomials that we have been working on. And so what I want to do is actually discuss this right here and then work a couple of examples for you. All this will be discussed as I go through the process. And so it says list all the coefficients in order from left to right, placing zeros for missing terms. That means if I have x cubed and it all goes to x to the first power is next, if I could talk, then I need to put a 0 in for the x squared. Now I don't have to put the x squared in dealing with synthetic division. If the value is given, put it in a box. If a polynomial is given, change the sign of a number and put it in a box. And I'll show you that in a second. Draw an equal line. Multiply the number in the box by the bottom number and put the answer under the you can read that. I'm not going to read everything to you, and you need to make sure you have all those down. But here's the box, here's the equal bar, and the process is this. You put your number here, and I'll discuss the number that goes there. Your first number falls down, drops down, and every number that's below this bar you multiply by what's in the box. Put the answer to the next spot. You add or subtract anything that's on top of this bar based on the signs. Then the answer goes down here. Once it's down here again, you multiply to the box, and then you move it over. Add or subtract. Put it down here. Multiply. The last column is always your remainder, and each one of these numbers here will be the new coefficients of your new polynomial that goes down a degree. That's what this is saying. Number 6 tells you how to write your answer. The numbers under the equal bar actually form the coefficients of the quotient or your answer, but they go down a degree. Down a degree from what? From the original dividend or the original polynomial that you divided into. Okay, so let's work a couple of examples. Okay, so now we're going to divide using synthetic division. First thing I need to tell you is that you cannot do synthetic division on every problem. Only the problems that are written like linear. And what I mean like linear is your divisor. That means the number that goes outside of the dividing symbol. Or the second one when it's written like this, or the denominator when it's written as a fraction. Has to be x by itself plus or minus a number. You can't have a number in front of the x being multiplied like 3x. You can't have x squared. It has to be just x plus a number or x minus a number. Now, I'm not sure, I don't remember, I put that in the notes, but you might want to write that down. It's very important. So let's take this and do synthetic division. And this kind of turns out to be our playing board, so to speak. This is my equal bar. That's the box. Whenever you're given something like this, what you do is you take the opposite of the number that you see inside of there. The opposite of that number is -5. Now, what I'm telling you when you look back at the notes is if I actually tell you that x equals 5, or if I actually tell you that f of x equals, 2 or something, if I tell you the value to use, then you have to use that right here. But whenever you're given a polynomial, you have to change the signs when you use synthetic division. That's very important, okay? So it depends on what's given to you, all right? So now I list all the coefficients here. What are the coefficients? 1 for x squared, 6 for x to the first power, and 15 for the constant term. All right, I didn't have to put 0 in for anything. The process is drop your first number down. And so 1 times -5 becomes -5. Once it's up here, you add or subtract. Since those signs are different, you subtract. You do it again. 1 times -5. And 15 minus 5 is 10, and this is where you stop. Now, remember, the last column is always your remainder. This is your new answer. It just goes down a degree. But how do you write it? If the degree here was 2 in the dividend, now the new degree is going to be 1, or to the first power, plus 1 plus 10 over x plus 5. You get the same thing. Now, if I did long division here, just run through that real quick. What do I multiply this by to get x squared? Is x. X times x is x squared. X times 5 is 5x. Draw my line, change my signs, and I get x. Bring the 15 down. I multiply this by 1 to get x. 1 times 5 is 5. Draw your line, change your signs, and look, you get the same thing if you do long division. But look how little work I had to do. Look how much writing or less writing I had to do here. So you get the same answer. You can always do long division, but synthetic division is a shorter way if your problems look like this. Let's look at number 2. I'm going to set this up. Remember, if it's written like this, what you want to make sure you do is change your sign of your divisor. Alright, so let's list the coefficients. X cubed is 1. Notice I don't have an x squared, nor do I have an x to the first power. So x squared get a 0, not 0x squared, not like how we would do up here, where we would put the x squared. I don't need that. I'm just going to put 0 for x squared, and then 0 for x to the first power, and then negative 20. That's not just 20, that's negative 20 there. Alright, so again, that number always, if it's written as a polynomial, x plus or minus something, you just change the sign and put it in the box there. And you write next to it all the coefficients of your dividend. And I'm missing the x squared and the x to the first power, so that's why I write it like this. Bring your 1 down, or your first number down. 3 times 1 is 3. You add those, you get 3. 3 times 3 is 9. You add those, you get 9. 3 times 9 is 27. You add those two, which you end up subtracting, and you get 7. And remember, that last column is always your remainder. So, how do we write our answer? Well, it started off in the dividend as x cubed. So when we go down a degree, this is going to be 1x squared plus 3x plus 9 plus 7 over x minus 3. These become the coefficients of your new polynomial, but it goes down a degree from your dividend. Alright, I've shown you how to do synthetic division. Another useful tool for using synthetic division is if you want to evaluate a polynomial. And when evaluate a polynomial is like when I ask you, or they ask you, to tell me what this equals if I put 4 in for x. Let's try that real quick. If I put, not p, but 2 times 4 squared minus 5 times 4 minus 3, order of operations say you get 2 times 16 minus 20 minus 3. 2 times 16 is 32 minus 20 minus 3. 32 minus 20 is 12. 12 minus 3 is 9. Let's see if we'll get the same thing if we do synthetic division. Now remember, if I tell you what to use, then you don't change the sign. As I set this up, I'm going to tell you what to use now for your box. And so I don't put negative 4, I just put 4. And I also put 2, negative 5, and negative 3. These are the coefficients here. Alright, remember the process. Bring down the first. 4 times 2 is 8. Negative 5 plus 8 is 3. 4 times 3 is 12. Negative 3 plus 12 is 9. Whenever you do synthetic division and you're trying to evaluate, your remainder turns out to be what it would be if you just substituted that number in for x in a polynomial. So if you ever have to substitute into a polynomial and they say evaluate, they just want to see what it equals when you make this number, put this number in, then the remainder would be your answer. That's another useful tool. Another way that they write it is, you can't hardly see it, but it says p of x, like up here. P of x, alright, p of x equals this equation here. But notice that instead of saying x equals -1, they got it written in what's called function notation. That simply means if this was p of x, see how the -1 is where the x will be? They're just basically saying substitute -1 in for x. I can go through and show you that, But I'm going to do synthetic division. And so when I do synthetic division, to me it makes it a little bit quicker and easier. I put -1 in for x. Again, I already know what my box number is. I don't have to change the sign because it wasn't given to me like this. It wasn't written like x minus 1 or x plus 1 or something like that. It was already given, a number was already given to me. And so the coefficients will be 4, -5. I don't have x to the first power, so that's a 3, and then 0. All right? Bring your 4 down. Always bring your first number down. -1 times 4 is -4. Those two become -9. You multiply those two, and that becomes 9. 0 plus 9 is 9. -1 times 9 is -9. And so 3 minus 9 is -6. So the idea is, if I take -1 and put it in here, I should get a -6. Let's see. 4 times -1 cubed minus 5 times -1 squared plus 3. Let's see if that equals a -6. And so -1 to the third power is just -1, so this becomes -4. -1 squared is +1, so that just stays -5 plus 3. That's -9 plus 3, which is -6. So it works. So again, what am I showing you here? I'm showing you that if you ever have to figure out what a polynomial equals if x is a certain number, you can use synthetic division and your remainder turns out to be what that would be if you actually went through this process of substituting it in. Alrighty, Merry Christmas.